So here we are. Our first lesson in this unit, guys, we talked about essentially the fact that square roots can't have what underneath them? Negative numbers, right? Can we put zeros underneath the square root? What's the square root of 0? 0. Good. Can we put positive numbers under square root? Yes, just not negative numbers, right? And so we talked a little bit about how to solve equations that have square roots in them, okay? Then we talked about how to break down radicals. We talked about conjugates and what conjugates will do. We talked about using the quadratic formula. We talked about imaginary numbers. And we introduced the concept of I and the fact that I is equal to the square root of -1. Okay? And then I think the last thing we discussed before break was the idea of complex numbers, right? Something like 2 plus 4i. Okay? And the last thing was solving quadratic equations that have complex answers. In other words, we can solve an equation like this by using the quadratic formula, and sometimes we get answers that are real, sometimes we get answers that are imaginary, okay? And that's kind of where we left off. And so the next 2 days are going to be focused on something called the discriminant. Guess what? You already know what the discriminant is, okay? You don't know what it is quite yet, but you know what it is. What's b squared minus 4ac? Is that something that we've talked about? Yeah, that goes underneath the square root when we use the quadratic formula, doesn't it? Well, guess what? B squared minus 4ac is called the discriminant, okay? And that's what we're going to focus in on for the next day and a half to 2 days. And then don't forget that we will have 2 days of new material, 1 day of review this week, and our test is Friday, okay? So we're gonna ease back in, okay? We're gonna ease back in and have an extra day here to review. Sound good? Oh, that was kind of just like well, this is the way it's gonna be. So no quiz tomorrow. No quiz tomorrow. All right, so here's where we're at. We are looking at today the discriminant and the nature of the roots. Okay, those are 2 new words. All right, but the first one I said you guys already know. B squared minus 4ac is called the discriminant. And if you're ever not sure what the discriminant is, you can always look at the quadratic formula and look at the thing that's underneath the square root. So this thing will always match your discriminant. They are the same. Okay? Now, guess how you're going to find the discriminant? Well, the same way that you find b squared minus 4ac when you find the quadratic formula solutions. You're going to use your calculator. Okay? So in each of these cases, here's what I want you to do, okay? I want you to store in your calculator A, B, and C. So for this first example, my A is 1, my B is 4, my C is 13. And go ahead, and I want you to find 2 different things, guys. Ready? The first thing I want you to do is tell me what this equals. And then I want you to find the roots. And I don't care how you find the roots. You can polyroot it, you can graph it, do whatever you want to do to find the roots. And again, guys, remember that when I do this piece right here, what do I got to remember to do? Times, right? Yeah, if I put AC, it's going to give me an error, so I got to do A times C. Did you guys get this for your discriminant? Okay, good. All right, negative 36, right? And again, that's just plugging them in and being able to use the calculator. All right, so the discriminant, negative 36, okay? Before break, I had you guys kind of on automatic mode. If I ask you to find the roots, first thing you're always going to do, polyroot it, absolutely. Automatic, find the roots. Now, here's the thing, guys. Do we know what the roots are? Do we know if the roots are real or complex? Do we know? No, we don't. But hang on a minute. Time out. Time out. Hold the phones. We just did b squared minus 4ac, right? What'd we get? Negative 36. If I was using the quadratic formula, wouldn't that negative 36 go under the square root? Is that good news or bad news? Bad news, right? If I take the square root of a negative number, I'm going to wind up with what kind of roots? Real roots or imaginary roots? Imaginary, so I'm going to go to complex because I know what's going to happen. So I have a 1, a 4, and a 13. And it gives me my roots. Negative 2 minus 3i, negative 2 plus 3i. Now, what if you made a bad choice? What if you thought the roots were real? What would it have given me? The empty set with nothing in it, right? Which would have meant that I would have went back and done the complex roots anyways. All right, so negative 2 plus or minus 3i. Negative 2 plus or minus 3i. All right, now, this is where we're going to have a conversation about what these words mean. The first question is this. How many roots are there? Now, when I ask you that question, right, it appears that there are 2 of them, right? But they are 2 what kind of roots? Imaginary roots, right? If I graph this parabola, is that graph going to cross the x-axis? No, right? It's not. That's why the roots are what? Imaginary, right? So I'm going to have no real roots, or 0 real roots, because it asks for a number. I'm going to have 2 imaginary roots. I'm going to have 2 imaginary roots. Now, without even graphing this, guys, without graphing this at all, here's what I know about my sketch. Give me one thing that I know about my sketch. Guaranteed, no doubt about it. The y-intercept is 13. Yeah, I know that for sure. Give me another thing that I know undoubtedly about my graph. It doesn't touch the x-axis. Give me one more thing I know about my graph. It's happy, right? So it's going to look something like this, right? Now, it's not crossing the x-axis. It's happy. It has a y-intercept of 13. Now, this is the sketch, right? Do I know exactly what this thing looks like? No, but I know that these sets of facts are true. Could I plug it in the calculator and look at it? Sure. All right. So this is one case, guys. Now, what do I mean by case number 1? There are 4 things that can happen when I find the discriminant. 4 things. This is one of them. No real roots, 2 imaginary roots. Sketch looks like this. So far, so good? Okay, let's look at the next case. All right, we're going to go through the exact same process. A is 1. All right, so I have 1, I have -8, I have 16. Let's see what we get. 1, -8, 16. B squared minus 4AC gives me what? Gives me 0. Okay. Well, is 0, I asked this earlier, is 0 allowed to go under the square root? Yes, okay. So are my roots going to be real or imaginary? Real, because you guys said it's okay, right? So when I go to polyroots, real roots, 1, -8, 16. That's weird. 4, 4. Guys, if I said, what's 3 plus 2? You would say it's what? 5. You would say it's what? 5. You would say it's what? 5, right? Everybody's going to say it's 5, right? So I'm going to have what? 30 answers of what? 5, right? So even though I have 30 answers of 5, how many answers did I have to the problem? 1. Everybody gave the same answer, right? So I have one answer 30 times, right? That's kind of what this is saying. This is saying I have answers of 4 and 4. So how many roots are there? 1. And it's just what? 4, yeah. So the root is 4, right? The root is 4. It's called a double root, guys. It's called a double root. A double root is one that happens at the same spot, okay? So number, I have 1 real root. I have 1 real root. My sketch, give me some things that I know are true. Thing number 1 is I have a y-intercept of 16. It's happy, and it has a root where? At 4. So what is this graph going to look like? It's going to be happy, it's going to hit this spot, and what? Kind of bounce back up, isn't it? All right, that's the only way that I can have 1 single root, is if it hits it and bounces at that spot. Cool? All right. So far, my cases, ready? My discriminant here was what? Was 0, correct? So if you're building things in your mind right now, this is what you should be building, right? If the discriminant is -36, I have no real roots, I have 2 imaginary roots, and it looks like this. Okay? If my discriminant is 0, I have 1 real root, and it looks like this. It bounces, it hits it 1 time only, 1 real root. Okay? So what are our other possibilities here? I could have a positive number, right? So far we had a negative discriminant, right? We had a discriminant of 0. Now we're going to get a discriminant that's positive, and let's see what happens here. So here my A is 2, -7, -4, 2, -7, -4. $81. Everybody agree? Is that a number that's allowed to go underneath the square root if I applied it to the quadratic formula? Absolutely, right? So I would imagine, so my roots are going to be what? Real or imaginary? Real. Okay, good. So b squared minus 4ac equals 81. So I know my roots are going to be real. Let's find out what they are. Real, 2, -7, -4, -1/2, and 4. So how many roots do I have? 2 real roots. Now, I'm going to actually add something to this in a minute. I'll talk about what that additional word is after I do the next example, okay? But what is my sketch going to look like? Well, y-intercept at -4, a root at -1/2 and +4, and a happy or a sad parabola. A happy parabola. So it's going to look something like this guy. Would we all agree? Again, we're going to fill in that box in a minute. But what was our discriminant? Our discriminant here was 81. Okay, we're going to add to this description after we complete the next example. All right. Discriminant. A is 1. B is -10. C is 13. I'm going to rely on you guys to do all this one for me, okay? B squared minus 4ac, what you got? You're still typing, I'll wait. I heard 48. Okay. 48. Forty-eight's a positive number, right? So when you polyroot it, you're going to look for real roots. And you got real roots, right? Go ahead and read those. Read one of those to me, please. Say it again, louder. 1.5359. Okay, and the other? Okay, guys, if I was to ask you to compare the roots here to the roots here, would you agree that I have 2 real roots? Okay, 2 real roots. That description's exactly the same, yes? We're going to fill in this box in a minute. I want you guys to think about how I could describe them a little bit more accurately in a second, okay? We'll do our sketch. Y-intercept of 13, a root at 1.5-ish and 8.5-ish, about, right? We're rounding, and a happy parabola. So it's going to look something like this guy, right? So would you guys agree that the sketch here in our 3rd example and 4th example is very similar? 2 roots, real roots. What can I do in these boxes to be a little bit more specific about the difference between this and this? Well, before you answer that, the discriminant in the 3rd example was 81, right? The discriminant in the 4th example was 48. How would you describe the difference in the roots here and here? Which one do you like writing down better? Example 3 or example 4? Example 3. Do you guys think that these answers right here are exact? Why not? What do you think happened? What do you think happened? Why are they not exact? What did we do? We probably rounded these, fair to say? So give me a word comparing this to this. What are the roots in example 3 as opposed to the roots in example 4? You learned about this in regular algebra class, probably on day number 1. Rational. These are rational roots, right? Remember, rational roots are roots that are either integers or fractions, like that, right? Rational means it can be made into a fraction. Would you guys agree that these are irrational roots? There's some sort of decimal that doesn't repeat. Okay, can you now connect the dots? What type of discriminant gives you rational roots? You're saying the right thing the wrong way. You're saying, you got it. Not a square root, but a perfect square, right? If you have a discriminant that is a perfect square, is 81 a perfect square? Yeah, what's the square root of 81? 9, right? Is 48 a perfect square? No, now I want you guys to think about the quadratic formula, right? This 81 gets plugged into the quadratic formula, right? And what do you wind up doing? You take the square root of 81, right? And you get 9, which is why you get nice roots. Now, if you put 48 into the quadratic formula, you have the square root of 48, which is not a nice number, right? Which is why you get irrational roots. So here's the connection. Ready? This sort of describes everything that we just did. This describes everything that we just did. If the discriminant is, ready? Write this word down, negative. If the discriminant is negative, then that guarantees you imaginary roots. Guarantees it, right? If the discriminant, so case number 2, if the discriminant is 0, right? If the discriminant is 0, that means you have one real root. And we saw that, right? That's the what? That's the one that bounced off the x-axis. If you want to use that word, guys, go ahead. It's a bounce root. A bounce root's a double root. Same thing. If your discriminant is a perfect square, right? Example, 100, 49, 9, 16, 121, 4, right? If you get something like one of those, then what do you have? You have 2 real rational roots. And if it is a positive non-perfect square, right? So a non-perfect square. So the example on the previous page, 48, 7, 11, 101, 3. Then what do you have? You have 2 real irrational roots. And we saw pictures of all of these. Okay? So guys, are we really doing anything new per se? We're sort of using the quadratic formula to complete a task, right? To figure out what these look like. Guys, these words right here, do you see this column? Please circle this. Please circle this. Please star this. Anytime I ask you for the nature of the roots, I want you to tell me how many of them there are and what they are. Is there one root? No roots? 2 roots? Are they real? Are they imaginary? Are they rational? Are they irrational? Right? So you're using this column to describe. All right, so let's just do a couple of these and we will be on our way. I'm going to give you guys about 5 minutes, and in these 5 minutes, all I want you to do is get me the discriminant for these 6 examples. I don't want you to describe them. I just want to know what is the actual number of the discriminant. What did we get for A? That wasn't very convincing. What did we get? 81. For B? 36? Negative 36. For C? 81, negative 36, 0. Okay, for D? Negative 24. E? 28? 128. And the last one? 25. Okay. I'm going to assume that you're all right. So, have I described the nature of the roots? Have I? No, I've simply found the discriminant. Okay, so this is the follow-up step, right? Because the directions say determine the number and nature of the roots. So, 81 is a positive perfect square. So I know this is true. 2 real roots. Guys, anytime I have a positive number, how many roots am I going to have? 2. Are they going to be real or imaginary? Right? So I know that this is 2 real roots. I know that this is 2 real roots. Guaranteed. Guys, if my discriminant is negative, what do I know? Guaranteed. My roots are imaginary. So I have no real roots, but I have 2 imaginary roots. Okay? If my discriminant is 0, I have 1 real or imaginary? Real, because I can take the square root of 0, right? 1 real root. Okay, now, still haven't fully described the nature of the roots, because now I have to say whether or not the roots are rational or irrational. And a number that is what gives me a rational root? Perfect square. So 81, is 81 perfect? So these are rational. 2 real roots that are rational. Guys, if I have 1 real root, right, this is also going to be rational, right? This one is always going to be rational. If you get 0, you're always going to have a rational root. This is going to be irrational, right? I can't take the square root of 128 is not perfect. And 25 is rational because 25 is a perfect square. Okay? So again, to describe the nature of the roots, how many? Are they real or rational? I'm sorry, are they real or imaginary? Are they rational or irrational? Everybody understand the process there? All right, cool. Which of the following, when graphed, would not cross the x-axis? Now, guys, this is an exercise in one do you understand the tools that you have at your disposal? And do you really understand the math? Guys, think about this for a minute. Ready? Check this out. Is this going to be a happy or sad parabola? Happy. What's the y-intercept of this one? -3. Hey guys, look at me. If I have a y-intercept at -3 and it's a happy parabola, will it cross the x-axis? Has to, right? I mean, there's no way I can cross through this and be happy and not, right? So this says which one of these would not cross. So choice 1 definitely will. Hey, how about choice 2? Choice 2 is what? Sad with a y-intercept of what? 6. Oops. So if I, this is, what are you doing? What is this thing doing? Stay here. Don't go anywhere else. Thank you. All right, so if I have a y-intercept of 6 and I have a sad parabola, right? The only way I can have a sad parabola is if I go through the x-axis, right? So choice 2, no good. All right, so now I have choice 3 and choice 4. Choice 3, what? Has a y-intercept of 5 and is happy. So this is choice 3. A y-intercept of 5 and is happy. Guys, what could happen? I could either do that. Does that cross the x-axis? No, but I could have also done this, right? So it could be 3, right? And can I make the same argument for choice 4, right? So this is a case where now I got to use the discriminant to figure out which one does not cross. So what am I looking for? A discriminant that is negative. Absolutely. I'm looking for a negative discriminant. I'm looking for a negative discriminant. And so if I did choice 3 versus choice 4, guys, again, I understand that you could always do what? You could always plug this in the calculator and look at it visually, right? And that would be the best way to answer this question. But to sort of reinforce what we're doing here, what did we get for 3 for discriminant? -64. And how about for choice 4? 121. And so the one that gave us a negative solution was choice 3. Okay. And if you looked at choice 1 and choice 2, they would have given you positive solutions or a solution of 0. All right. We're not going to do 52. Don't worry about 52.